All right, so let's talk about another absolute value inequality. So let's say we had the absolute value of, I don't know, 2x minus 1. Let's go minus 3 because I want 3. So 2x minus 3 is less than, let's go with 7. Okay, so if you think about this again, about distance from 0, we want all the points. Here's 0. This absolute value has to be less than 7 away from 0. All the points less than that. So 1, 2, 3, 4, 5, 6, 7. But it wouldn't include 7. And then 1, 2, 3, 4, 5, 6, 7. And so that's negative 7. There's positive 7. And so this absolute value has to be between these numbers right here. So this is an and again, because again it's everything in between 7 and negative 7. And you could have again used that little mnemonic, less and. But since it's there's some stuff, there's some stuff inside this absolute value, we're going to have to set up some equations here to go even further because we haven't found what x has to be to get a number less than 7. And so since it's and, we have two that we would actually use. We'd have the stuff that's in the absolute value is less than or equal to 7, and that stuff inside the absolute value could be greater than or equal to, oh, there's no equal to sign. I see, I added that. Sorry, when I underlined it. Um, or, and 2x minus 3, that stuff, is greater than negative 7. So you flip the inequality because it's, you got to left all of these points going this way for this one. And for this one, it's all of these points coming this way. And the and ensures that it's the overlap, so we don't have anything out here or anything out here. We don't want that stuff in our answer. Okay, so now it's just a matter of, now that that's the hard part. Okay, once you get through that, it's easy. Okay, so 2x minus 3 is greater or less than 7. So you would add 3, just like this was a regular equation. 2x is less than 10, and so x is less than 5. Over here, 2x, I'm going to add 3, is greater than negative 4, so x is greater than negative 2. And it's still an and in between there. Remember, we don't write it in this form when it's an and. We combine it into one sentence. You start with the smallest number, put your variable in the middle, put your largest number on the right side, so you're going least to greatest, and then just fill in where the inequalities go. So less than, negative 2 is less than x is less than 5. So this is our final answer, but we probably should graph it just so we know what's going on. So here, 0, 1, 2, 1, 2, 3, 4, 5. It would be an open circle at 5, an open circle at negative 2, and all the points between them. And so that's the solution to that. Now let me give you one more. So that was an and. Let's give you the opposite, an or one. So let's say we had the absolute value of negative 2x minus 5, absolute value, is greater than or equal to, I don't know, let's go with 9. Okay. So again, thinking back to this absolute value has a distance of more than 9 is what this says. So the absolute value has a distance of more than 9 from 0. So if you kind of rough sketched that, here's 0, here's 9, here's negative 9. And so we're looking at all the points more than 9 away from 0. And they would also include 9 and negative 9. And so in this case, since they're going away from each other, and we've got all of these work and all of these work, we've got to have an OR to include them both. So, and it would be great if we were done, but unfortunately we've got a bunch of stuff inside of here. And so we've got to set up two equations. Negative 2x minus 5 is greater than or equal to 9, or negative 2x minus 5 is less than or equal to negative 9. And again, this equation goes with that side. Getting blued out here. This equation goes with this side. So this is all that stuff greater than 9. And over here on the right side, that's over here. It goes with anything less than negative 9. So there's where they both are located on that number line. Now I'll just solve it just like we have been doing forever. So you'd add 5 to both sides. And so you'd have negative 2x is greater than or equal to 14. And then divide by negative 2. When you divide by negative 2, remember that flips your inequality. And so x is less than or equal to negative 7. On the right side, same thing. Negative 2x, you'd add 5 to both sides. And so negative 2x is less than or equal to negative 4. Again, divide by negative 2. When you divide by the negative 2, it flips your inequality. X is greater than or equal to 2, and there's an OR between them. The beauty with OR is we can leave that conjunction alone, and it's going to stay OR. And so that is your final answer algebraically. On the number line, it looks like this. Here's 0, 1, 2, 3. There's 2. It would be a closed circle for the equal to part. 1, 2, 3, 4, 5, 6, 7. There's negative 7, also a closed circle. And since it's x is less than or equal to negative 7, that goes to the left. And x is greater than or equal to 2, that goes to all the points to the right. And if you indeed substituted these back in, I've been getting kind of lazy. So if you took negative 8, for instance, and plugged it back into the original equation, it would in fact be greater than or equal to 9, just like if you took the point 3 and plugged it into the equation, it would also be greater than or equal to 9. Any point inside of here, these would be false. They wouldn't work at all. So you could put 0 in there. And I got time. Let's put 0 into that original equation and see what we get. And so we'd have absolute value of negative 2 times 0 minus 5. Okay? Negative 2 times 0 is 0. That would be the absolute value of negative 5. We know the absolute value of negative 5 is positive 5. Is that greater than or equal to 9? And that's a big false. So we know points in between 2 and negative 7 will not work. And points outside of 2 and to the left of negative 7 will work. And I forgot to, again, do this in set notation. So for this left one, we're starting at negative infinity, and we're going to 7. Including 7, or we're starting at 2. Oops, excuse me, and I gave the wrong symbol. We're starting at 2 and going on to positive infinity, but we can't include infinity because it keeps going and going and going. And so there's your set notation for that particular problem. So mathematicians always trying to find another shortcut so they don't have to write anything down. Write big long sentences down. All right. Good luck. Hope this helps, and see you next time. Again, if you have questions, make sure you ask. Post them in the comments, or come find me. Those of you who know who I am. See you later.